All right, today we're going to cover 8.4. We're going to continue talking about rational expressions. Specifically today, we're going to simplify and then we will multiply and divide those. So we are going to have to rely very heavily today on remembering how we're going to factor. So I will shortcut these to a certain extent. If you need a further review, you can go back to the last lesson and watch that, or you can always send me an email and I can go over that deeper, but it's definitely something we've done before. All right, so let's start with number 1. We're going to simplify the function x squared plus 7x plus 10 divided by x squared minus 3x minus 10. So remember, when we want to factor a trinomial or quadratic trinomial like this, we need two numbers that multiply to be c and add to be b. And so here you'll notice it's c and b, c and b. So as we do this, for our numerator, we want two numbers that'll multiply to be 10 and add to be 7. So if we look at that, that's actually going to be x plus 5, x plus 2, because 5 times 2 is 10, 5 plus 2 is 7. Divide that. We want to multiply to be negative 10, add to be negative 3. So that's actually going to be here x minus 5, x plus 2. All right, we will go into the simplification process, and you can see here that we can cancel out that x plus 2 on the numerator and denominator. We will be left with x plus 5 over x minus 5. Now, we're not quite done because we have to talk about restrictions. And so even though we canceled out that x plus 2, we still need to set that equal to 0 and solve it out. X cannot equal negative 2. And then we have the x minus 5, set that equal to 0. X cannot equal 5. So we're going to write that in our answer. X cannot equal 5 or 2. Negative 2, I'm sorry. Okay, so that should be it for solving number 1. Now I'm going to make a note up here at the top that's going to apply to the rest of our problems as well. Restrictions, how we find those. We want to set all factors in the denominator equal to 0 and solve. So using that logic, we're going to go down and work number 2. Now you'll see here that we do not have quadratic functions like we did above, but we can still simplify. And the way we're going to do that is we're just going to isolate like terms. So we can simplify 24 divided by negative 6. We can simplify our x's, and we can simplify our y's. So the way we're going to do that is, if you remember, when we have x cubed over x squared, it's simply the same as x to the 3 minus 2. So we're going to write all of that out just to be clear. So all of this equals 24 divided by negative 6 is negative 4. Now we have x to the power of 3 minus 2. Notice we're just subtracting those exponents. Y to the power of, let's see, y to the power of 2 minus 3. Okay, if we simplify that further, we have negative 4x to the 1, y to the negative 1. Now we don't like negative exponents, so that will have to be moved to the denominator. So if we simplify that one last time, we will have negative 4x. We do not need to write to the power of 1, that is implied, divided by y. We do not have to write to the power of 1, that is implied. Now here we have restrictions as well. You'll notice that these variables here are on the denominator, and we know that we cannot divide by 0. So we will say x cannot equal 0, y cannot equal 0. Okay, moving on to question number 3. Here we have x squared plus 2x minus 8 divided by x squared minus 5x plus 6. Since we have quadratic trinomials, we will factor those. Go ahead and try that on your own, and then I will write them up here to check your work. All right, when we break that down into its factors, we have x plus 4 times x minus 2 on the numerator. We have x minus 3 times x minus 2 on the denominator. We will see here that if we look to cancel, we can cancel out that x minus 2. That leaves us with x plus 4 over x minus 3. Now, even though that's simplified, we still need to look at setting both factors in our denominator equal to 0. So we can say that x cannot equal 3 or 2. Notice that the shortcut there is just to change the sign, since we have that factor as a single x minus or plus a number. We can just change the sign on that number, and that's what x cannot equal. Okay, last one on this page, we've got 12 minus 4x over x squared minus 9. When we go to simplify that, on our numerator, I can actually factor out a negative 4. That will leave me with negative 3 plus x. Now, it's important that I factor out the negative 4 here, as opposed to just 4, and you'll see why in just a minute. Now, if we factor the denominator, x squared minus 9, this is actually a perfect square binomial. So what we can do is we can just say this is x plus 3, x minus 3. So you'll notice we took the square root of 9, which is 3, x plus that value, x minus that value. Okay, the reason that factoring out negative 4 was important is because now we have basically x minus 3. Even though they're written in different orders, it's the same thing. So we can now cancel out x minus 3. We are left with negative 4 divided by x plus 3. And our restriction here is x cannot equal 3 or negative 3. As we start to practice this, it will become easier and easier. So now we'll discuss multiplying and dividing these rational expressions. You'll see here that we have x squared plus x minus 6 over x minus 5 times x squared minus 25 over x squared plus 4x plus 3. And so the easiest way and fastest way to solve this is going to be to break this down into its factors first to see if anything will cancel. Because when we're multiplying these, we can simply push everything together, and we'll see how we do that. So let's start by factoring. Here in our first quadratic, we need two numbers that multiply to be negative 6, add to be positive 1. And so if we work that through, it will be x plus 3, x minus 2. We want to do the same for this other numerator, x squared minus 25. So that's actually going to be x plus 5, x minus 5. Down onto our last quadratic, we have x squared plus 4x plus 3, multiplies to be positive 3, adds to be positive 4 is x plus 3, x plus 1. All right, now basically that has replaced all of those quadratics, and we can go to try to cancel. So you can see we can cancel the x plus 3, we can cancel the x minus 5, and that looks to be it. So we are left with x minus 2 times x plus 5 over x plus 1. Now, we still have to look at our restrictions. We want to set each of these terms equal to 0. So x cannot equal 5, negative 3, or negative 1. So it looks much more complicated than it is. If we go ahead and we break down those quadratics at the beginning, it makes our lives a lot easier. Okay, last example of the day, we're going to divide rational expressions. So here, we're going to break down those quadratics. I want to know, what can I break down that multiplies to be positive 1, adds to be positive 2? I think that will be x plus 1, x plus 1. What two numbers multiply to be negative 10 and add to be 3? That will be, let's see, is it going to be x minus 2, x plus 5. Yes, that would be right. And then down here we have x squared minus 1, so that breaks down to be x plus 1, x minus 1. Okay, now that we've done this, we've replaced those quadratics. Now, remember, there is something special we do when we're dividing fractions, and there's two ways I've heard this. Some people say keep, change, flip, and I have also heard just flip, then multiply. So what we do is we keep this fraction the same, we change the division to multiplication, and we flip the last fraction. So we're going to keep this one the same, 2 minus x over x plus 1, x plus 1, times, we're going to flip this second fraction, x plus 1, x minus 1 over x minus 2, x plus 5. Now we can just multiply across after we cancel. So I'm looking, I see x plus 1 on top and bottom. I see nothing else. However, if I go over here and I say factor out a negative 1, that would leave me with negative 1 times x minus 2. Now I can go through and I can cross out the x minus 2's, and I just have to make sure to keep this negative 1 in my system. Okay, so that leaves me with negative x plus 1, x minus 1 over x plus 1, x plus 5. All right, and then we just need to talk about our restrictions. So we have to set each piece equal to 0. For that reason, we're going to say that x cannot equal negative 1. That comes from here. X cannot equal 2. That comes from here. X cannot equal 5. That comes from here. We also have to think that x cannot equal 1, and that came from before we did the flip. So our restrictions will be x cannot equal negative 1, 1, negative 5, or 2. And that's as far as we have to go on that problem. So this was arguably the longest one of these, and I would say it is still pretty manageable. All right, that is the last section before we're going to take our quiz. So make sure you do your Math Excel assignment, and then go ahead and review your other assignments, 8.2, 8.3, 8.4. That way we can be ready to go for our test next class period.